the VIO is generating input. Okay, the output is again. So we can display through VIO or ILA. That's all. No pins connection is not required. It is internal logic IP testing. Right? If you want to connect externally, if you give inputs. So for example, after programming the FPGA, this is FPGA, you program this multiplier. Okay, this is multiplier logic implemented on the FPGA. And the pins will be there, all the pins. There are so many pins will be there here. Okay, so for these pins, if you want to test it, so you have to assign this multiplier is 8 bit. This inputs are 8 bits. Product is 16 bits. Okay, if you want to test these inputs, you have to feed through some external input. The switches are maybe any test generator logic. So this is the external input supply to connect. Then all these 8 pins you have to connect to these FPGA port pins. Again, these 8 pins will be connected to 8 FPGA port pins. The 16 pins also you have to connect to 16 pins of the FPGA port pins. 32 pins are required. So here 8 plus 8, 16. Here 16, 32 pins. 32 pins they are used. But without using this external connection, what we are doing is, so we are actually using on IP, VIO, one IP. This IP itself it is feeding to this simply inputs internally. This is internal to the FPGA, inside the FPGA. Output also same. Okay? So right. This by one IP is there inside the FPGA. And that VIO IP is generating test inputs to this. So you not feed external inputs, external output will not come. The pins connection is not required. Okay? So only one this IP clock connection only had to be one clock pin, external clock pin, because external clock source is there. This is a clock signal is going. Clock signal is there from one pin. Right? That clock only we have to connect to this. That's all. Nothing else. Only one pin assignment is required. Okay, understood this? So that clock pin is a default only, one pin number, it is a fixed pin only always. So that is Y9. Y9 pin, one pin is assigned to clock. Clock is connected on the board to one particular fixed pin only. That pin only assigned clock pin. Okay. Then next is you have to create one constraint file. Constraint file is pins assignment file only. That is XDC file. That file is a constraint file that will contain only these pins assignment. So right, save the constraint file with the name. So some name you have to give constraint file name. So demo is written here, demo. Then press OK. Then it will generate the bit stream. The next is you have to generate a bit stream. After doing this, next we have to generate a bit stream. Morning we have to generate a bit stream. That bit stream will be generated here. Okay. So after bit stream, then we can also see the reports also. So all these reports also, synthesis, after synthesis only it is going to come on this. So these reports are indicating that this logic block, how much power it is consuming, total power of 0.0185 power. Okay. Then temperature, thermal margin. Then here this is the RC power distribution. Dynamic power, static power. 98% of static power only it is consuming only. So 2% only dynamic power and 0.002 watts. Then again the dynamic power, the distribution, power distribution here. Okay. Then it will also generate new reports. If you click, then it will show all the synthesis reports. Okay. How many LUTs it is used, how many LUTs it is used, how much power consumption, how many VRAMs it is used. So that is also report also will come. Okay, that is not shown here. Okay. So this is the board actually, FPGA board. The Z board is Z board, 7020 Zinc FPGA board. Okay. So the next is validation. After creating this validation on the clock diagram, then create a wrapper file, create SQL wrapper file. After creating wrapper file, So then what you are doing here, you are assigning wrapper failure, assigning radix values to VIO. So here we are assigning the input outputs, right? Input outputs it will display like this. You just type the input outputs here, then you will get the output. VIO input outputs. Okay? So one input per VIO. Input is, what is the input per VIO? VIO input is output of the multiplier. VIO output is input to the multiplier. Okay? See, this is the waveform. This waveform is from ILA. ILA, because they are using ILA will give the output waveform. Okay? So, but this is implementation, after implementation of the board. Okay? What you do is now, so the Gopala Krishna is our research scholar, is doing his PhD here. Okay? So he is going to help you to do, you can do this multiplier logic on your own. Okay? Maybe you can also test on the FPGA board also. Then to complete that testing, then you can hands-on system. Okay? You can virtually you can implement and test it. Okay? So he will help you. Then he will demonstrate you. He will demonstrate step by step. You can follow that steps. So you just follow, you just power on all the systems.
Regard to 2018.3, click on it. Okay, go to the file. So create project.
You cannot complete, stop.
So as a desktop you have icon Vivado 2018.3. Go to the file. All of you go to the file. Okay.
Everyone.
Go to the file. Select the project. Click on new project. Click on it. Okay. So this window is open. Create new Vivado project. Next step. Click on next. So select the RTL project. Select the RTL project. Select the RTL project, click on next. Now in this one, go to the boards. It is showing jet code, zinc evaluation and development kit. So select that one. Click on next. Go to the boards. Select the jet board. Click on next.
Okay, done.
Have you done? So this is the project summary. So this is the device part number XC70020 CLG484. This is the zinc family. Okay. So this is our device part number. So this is the zinc 7000 product. So click on finish.
Create a project. Everyone create a project under this floor.
Okay. Next up. Go to the sources. Design sources. Okay. This one, click on plus icon. Go to the sources. This one, plus icon. Add sources. So click on that plus icon. Go to the sources. So click on plus icon. Here. This is the plus icon. Go to the sources. Click here. Plus icon. So you will be open this window. So in this window, you will be select the middle one. Add and create design sources. Now create the source file. So add and create design source. So click on next. Select the middle one. Add and create design sources. Click next. Okay. Here click on create a file. Click on create a file. Here give your name. So now we are designing multiplier. So give a multiplier. Underscore 8-bit. Any name? So file name you can assign any file name. So multiplier underscore 8-bit. Click on OK. Okay. Next finish. Click on finish. So now it is asking module name. It is not required. Click on OK. So click on OK. So the module definition has not been changed. Or you should want to change or use this value. So click on S. Click on S. So it is updated. So after that our module is created. This is our module. Mal underscore 8-bit.
Okay, done.
Double click on this module. So mal underscore 8-bit. So double click on it. Please open this window. This is our code right here. Okay. to write down the code. Time scale already there. Time scale 1 nanosecond में only just you can write here from here to here will be pattern code. These are not required, these are the comments. These are not required. Just module multiplier input A, input B, output, close bracket, and assign result A to B and module. That only. Total 5 lines. Completed code. After that, you can save it. Save the file. Here, this is the icon. Save the file or Control S. Click on save the file. Click on plus icon. Again click on plus icon. Go to the sources. Just click on plus icon. And the radar create the simulation sources for test bench. For test bench, select the radar create simulation sources. After saving the file, go to the sources. Click on plus icon and select the radar create simulation sources. So click on next. Click on next. Again create a file. Here write the name, file name, test bench. Okay, test bench. Click on OK. Go to the sources. Select, click on plus icon. Okay, so select the add or create simulation sources. After that, click on OK. So click on next. It will open this window. Create source file. Just give the file name. Any file name. Okay, so click on OK. So next, click on finish. Click on finish. It is not just click on OK. It is asking yes. Same, how to create the source file, same like test bench also. So click on plus icon, select the add or create the simulation sources and create a file, save it. Click on yes. So next that will be created here. See, this is the simulation sources. Expand here. This is the test bench or test bench. So what I created file, that is our test bench here. Expand the simulation results. So our test bench will be showing. Double click on that. Middle one for source file, last one for simulation. Okay, so here write the test bench code. I have to write down the test bench code. Here, type the code.
ఆల్రెడీ ఎగ్జిస్టింగ్ వస్తుంది.
Assign some values, any values. Test sequence, initial variant A value and B value. Copy first one type right, this one A equals to C equals to this one copy and paste here, just change the values. Top and the 45. We shall begin Okay, you can do later otherwise. Just copy the code. Go down. Now. Copy paste only one by one. Sequence is enough. Let us sequence, same sequence you can copy. This sequence you can take, type, same sequence you can copy multiple times. Just to change the values. A and B values you can change it. Last one it will be right this one, monitor the result. Take photos. Later you can do it. Okay. So now see, same code. After completing it, copy the code. You can save it. Okay. So next one it will be go to the simulation. This one simulation. Go to the simulation. Run. Click on run simulation. Click on run simulation. Just note down the steps. Simulation is not. Okay. So click on run simulation, run behavior simulation. Click on that. Okay, all of you done? So go to the simulation. So run simulation. Click on run simulation. Run behavioral simulation. Okay, completed. So now it is open one window, untitled window. So click on that. After completing the simulation, it will open one window, untitled window. Click on that, like the simulation results will be displayed here. Okay. Now, right click on this one. Right click on value, right click on this one. Go to the radix. Unsigned decimal. Select the unsigned decimal. Right click on this one. See, right click on this one. Okay, go to the radix. Select the unsigned decimal. This 255 value. Same like second one also. Right click on the radix. Select unsigned decimal. The third one also. So 255 into 255. So you multiply, that is the result. 65,025. Okay. Have you done? After that, click on Run. Go to the sources. Okay, go to the sources. Create the block design. So create block design. So give me the design name. Design one. So right side, left side. Now create block design. IP indicator. So create block design. Click on it. So it is asking name. Any name is given here. Design one or any one. Multiplier or design name is multiplier. Click on OK. Okay. So now go to the sources. So right click on multiplier. Go to the create block design. Create block design. Right click on the module. Right click on the module here. Module to the block design. Add module to the block design. Now click on plus icon. Click on plus icon. Here go to the block design. Click on the plus icon. Type VIO. Type VIO. Virtual input and output. Okay. Click on it. It is added. This is our VIO. Now just create block design. click on block design. Okay, right click on this module. Right click on this module. So module water grade. Right click on that. Select this one. Add module to the block design. So after that, click on plus icon. Click on plus icon. Type VIO. Type VIO. Click on plus icon. Type VIO. So virtual input output. Okay, click on it. So it will be created one VIO. So double click on that. Here, so how many input probes are required? Only one input probe. So the module output is input of VIO. So that's why one input probe is enough, and output ports are two required. So one input port, two output ports, and next one the probe input ports. Go to the here probe width. So what is the probe width? The input is how much? 16. Input is 16. Next the probe outputs. Go to the port output ports. So probe outputs is 8 and 8. Input A is 8, B is 8. Click on OK. Okay, click on OK. So now it is showing. So this is 7:0, 7:0. This is inputs. This is the output. One output, two inputs. These two inputs are connected to the two inputs of module. The output of VIO is connected to the input of module, and the VIO input is connected to the output of the module. Just drag it. Double click on VIO. So now probe count. Input probe count is 1. Output probe count is 2. The VIO output is input of module. Module is RTM. Multiplier underscore 0 is the module name. So now the probe width, input probe width is 16 bit. The result is 16 bit. Next the output port is 8 bit and 8 bit. Just click on OK. So now this will be modified. The probe output is 16. 0, 15 is 16 bit. This is 7, 11 is 8 bit and 8 bit. So just these two are connected to this two. This one is connected to this one. The VIO input is connected to the output of RTM. VIO output is connected to the input of RTM. Okay. Next click on plus icon. Again click on plus icon. Type ILA. Integrated logic analyzer. Click on plus icon. Type ILA. Integrated logic analyzer. Okay. Click on that. So ILA is created. So double click on that. So now select the NAT2. This option not AXL. AXL interconnect is we are not using. So NAT2. So just to connect the NAT2 option. Select the NAT2 option. And the number of probes. How many probes are required? 2 input, 1 output. Total 3 are required. So just type the 3. Select the NAT2 option. And the number of probes. 3 probes are required. Just type the 3. Okay. After that, probe width. Select this option, probe ports. So in this probe ports, the first one is 8, second one also 8, third one is 16. 8, 8, 16. Click on OK. Okay, click on OK. Now the 7:0, 7:0, these are the input of RTL. Just connect the input of RTL. Okay. Next, the last one, 16. The probe is output of RTL. Just connect to the output of RTL. This is the block design. Next, the clocks are there, two clocks, the VIO clock and the ILA clock. These two clocks will interconnect. The first one clock will be select and right click on it. One clock select and right click on it, and make external. This option, make external. Select the make external, click on it. Make external, click on it. So the external clock is created. So now this clock is connected to this clock. Okay. So now you can refresh it. This is the refresh. Refresh it. Automatically it is refreshed. So next one, validation. Our design is correct or not? You can check it. So this is the validation. Validate design. This option. So click on that. So validate design. So validation successful. There is no errors or critical warnings in this design. Have you done? This is the validation option. Just click on it. Okay. After validation completed, go to the sources. Go to the sources. Here sources is there. Here. So go to the sources. Right click on the design. Our design. What are the design? Right click on that. Create HDR wrapper. Create HDR wrapper. Go to the design, right click on that, create HDR wrapper. Click on that, it is asking auto update. So select the auto update, second option, that decoder manager wrapper and auto update. So click on OK. So our design will be modified. Previous is design _1, now design _1 wrapper. So it is updating. So wrapper is created. Okay. So now after that, go to the open elaborated design. Go to the open elaborated design. Click on it. The left side is the open RTL analysis. Please go to the RTL analysis, open elaborated design. So click on that. Okay. Elaborate design. After that, see, expand clock here. Just click on that. This is expand the clock and expand the scalar codes. So now clock underscore 0. So now only this pin you can select. So now here just click on that. This what are the pins available in Jetboard? All pins will be showing. Just type Y9. So Y9. So it is showing. Just select that one. And this is the default LV CMOS. The CMOS voltage you can select LV CMOS 33. This option you can select LV CMOS 33. 3.0. So select this one. So only expand the clock. In that clock, scalar codes is there. Expand again that one. It is showing clock underscore 0. This clock underscore 0 package pin you can select and say like VIO standard LV CMOS 33. Okay, after that you can save Control S. After that you can save Control S. So it is asking constraint file. So constraint file name. After select the pins, just to Control S, save. Asking name, constraint file name. Assign any name.
RTL analysis.
RTL analysis open elaborate design.
Hi.
Circuit suite implemented on the board and tested with the help of VIO and ILA. So VIO is directly can do the inputs to the keyboard and result will be displayed on the screen. ILA will show the waveforms. So, we'll close this session today and we'll meet again tomorrow morning at 10 o'clock.